Welcome back to another After Work special. My name is Garrett and this is Mojo Manufacturing. So as it would happen, the last week I made this little thing, the oil filter adapter, and I made this size. I cut it to the minor diameter. For some odd reason I modeled it that way. I'm not sure why, but it ended up contouring this outside part as the minor diameter. And I went ahead and remade this, and I really had to do a lot of fiddling around with the thread milling, with the pitch offset, getting the minor diameter set right from the major diameter. But we ended up messing around with it. I kept it in the machine until I got this right, and I kept it in there, put the oil filter, this is the oil filter that I'm going to use, and just kept going, whittling it down basically until it actually fit, until I got the right size with the thread mill. So here's the oil filter and here's the adapter, and it threads right in. Not a whole lot of play there either, so it worked out fairly well. Like I said, messing with the pitch offset in Fusion 360 was the hardest part, and we can go into that a little bit later, but I'm sure I don't have an 1 1/16 12 nut to check this side out. This is what originally came off the engine right here, and I sort of hold it up to it, and I'm pretty sure it's probably not going to work, just because I didn't have my offset enough when I did this side. So I will probably have to make another one of these for the third time, which is okay. It's still good practice for me, but that's just a little insight on what I did last week. So I'm going to try and redeem myself here from the last time I was trying to cut out one of those oil filter adapters, and right when I burned up that 3/8 end mill, that was a high-speed steel end mill, I am at that point now in this project. I'm making another one actually. I got to get the threads down. I got to get the threads on the big side down at this point. So I got some 3/8 end mills from Maritool, and now I'm at that point in the project. I also broke my GoPro case this weekend when I was hiking, so I'm just sort of going to hold this outside the enclosure so I don't destroy my GoPro. Just a recap from using the 3/8 end mill from Maritool, it ended up working pretty good for the first 10 seconds, and then it got to yelling at me again, got to chattering pretty good. So the only thing I could come up with is that the teeth on this is 3 flutes. So this is a piece of stainless steel, scrap stainless steel that I have. So it takes a lot more so one tooth is engaged, and it takes a lot more to go around to engage the next one. So that's the only thing I could really figure out that was going on. Each tooth, it was taking a lot more to get engaged to the material just because of its diameter. Maybe if I had a 4 flute 3/8, it would work a lot better because there'd be more teeth, and after one gets engaged, then the other is engaged much quicker. So I ended up going back to the 3 flute 1/4 inch end mill, and it's a lot smaller diameter, so that means every time that I turn, it's a lot less to go to the next flute to cut more material. So I think that's where the problem was hidden, was I just wasn't engaging enough. I tried to engage even more with a 3/8, and it's just still, I tried a whole bunch of different stuff, and it wasn't even worth going over on this. So here is the iterations that I've went through. This was the very first one that I did, and it is the one that I milled to the minor diameter. So this outside is the minor diameter, and it still milled the threads because Fusion 360, it doesn't care what the outside is, it just wants to mill the threads. It's really weird, but that's just how it is. So that one scrapped. This one, as you can see right there how bad that chatter is, that is from the 3/8 end mill, and I explained that to you why that did that. It starts just one fluid disengages and the other re-engages, and it's just way off and it starts jumping around. So it jumped around really bad right there. So scrap that one out, didn't even get to finish it. And the last two are actually good. I kept these threads the same, these 3/4 16, these top threads, I kept those the same. And these bottom threads right here, these are the 1 1/16 12 threads, and this left one has less offset than this one. So that means when I went around to profile with the thread mill, it actually engaged less with this one and engaged more with that one, giving it a deeper thread. So it would sort of match what this thread is right here, and this is what originally came out of the engine block. Now, hopefully this one works the best. Really, I hope both of them work, but I think this one will work, and this one will sort of get caught up in the threads, but we'll check that out. So let's go see if this thing fits. So I finally got it back, and this is the engine block upside down, and if you can hear that in the background, my dad is actually mowing right now. So this is it, goes in and then stops right there, and you can see this is the original one. It goes right there, and it's got a nice chamfer on the outside, and it sort of it goes right there, and it's got a nice chamfer on the outside, and it sort of 1.045, about 1.060. Technically that's not wrong for the 1.1 1/16 12 threads. However, this is probably a different class threads than what this this is closer to, well, I guess what they would call class 3 maybe, or is that backwards? Class 1? Class 3. So these would be tighter threads, so that doesn't work. So I'll have to make ones, and I'm going to go 1.045 on the maybe the major diameter. And some might be wondering, how in the world would I get this in there? Would I thread it all the way in there and get it tight? Okay, so what I would do is put a 3/4 16 nut on here and then tighten it down against it that way. And that's how I would do it if I didn't have any other way, but seeing as how I have this here, I'm going to just run this down on top of the 3/4 16 and run it in with this, with all these, the hex flats on this piece. And then you might ask, well, how in the world would you get it out? And my answer to that is, that's a good question. And because I see a bunch of people make these things, and they have you run it in with, basically there's a hex in here so you can put an Allen wrench in there and tighten it down that way and loosen it up if you need to. But I didn't want to sacrifice the surface area of the hex on here, because 4 to 460s apparently are notorious for bad oil flow. So that's what I'm trying to get away from here. Originally this diameter on the other ones is just straight 1/2 inch, whereas this one right here has the big bevel on the inside that we use with the radius end mill, and the inside diameter here is 0.547. So that's what I really liked about this, getting better oil flow basically for this whole thing, which I plan on racing. Anyway, back to the point of discussion, how would I get this off there? I would probably just use a set of channel locks or vice grips to get it back off there, but you really shouldn't ever need to take it back off there, honestly. You know, in these situations it sort of sucks because I live what's on basically the northwest side of Columbus, and my parents are back on the east side of Columbus, which really sucks because I gotta do stuff during the week up there, then come back on the weekend, and sometimes I work on the weekends, so I don't always come back home, so it might take a while to actually come back here and check the new one out, which ultimately kind of sucks, but that's okay. We'll get it done when it gets done, and that's it. Thanks for watching. Sorry for all the mowing noises in the background.